Before we start creating a continuous integration or continuous deployment pipelines, we first need to understand some basic terminology involved when you try to release a software. So in this section, I'm going to give you a quick overview of what steps are involved when you try to release a new software. The first step is, of course, you are going to write the software, and you are going to write these things in some couple of files. In the case of, for example, if you are using a C# kind of environment, you will write some .cs files, maybe some JavaScript or some C++ code. So once you write that source code, you are going to check in those changes into a central repository. So it could be something like GitHub, it could be something like Bitbucket or Team Foundation server. So there's a central place that you keep the source code so that you can version it, track changes, see what modifications has been done. And once you check in, usually you execute some build steps. So either you can build the software in your local machine, in your dev environment, but also once you check in, you kickstart some kind of a build process. So this build process is going to compile your source code. If you have some unit tests, it's going to run those unit tests. And if you are running some containerized application, it will also create the containers. So the build process is usually executed by some kind of a continuous integration system. So there are a lot of continuous integration systems like Team Foundation server, Jenkins, or some other third-party providers that provides different build systems. So once you build it, and let's say it publish a website, you are going to run some test cases, maybe manual test cases, or you want to run some load testing, or you want to run some UI testing. Maybe you want to do some security testing. So you execute a couple of tests, maybe manually or automatically, to identify any issues. So if everything passes at some point in time, you are going to deploy this solution into production. So prior to going into production, maybe you deploy this solution to some kind of a staging environment. But at the end of the day, you are going to publish this solution to the production environment. So in this software release journey, if you have automated your build system in a way that from the time that you check in, it get automatically built and then run some unit tests, for example, then you have implement a continuous integration pipeline. So which I mean by that is that you don't need to manually go there and then run these unit tests. You don't need to make sure that it compiles by executing the build process manually, but the system automatically execute the build steps from the time that you check in. So in that case, you have implemented some kind of a continuous integration system. If you can deliver this into production directly with some kind of manual intervention prior to going into production, then you have created something called a continuous delivery system. So it still goes to production with some sort of manual intervention, but you have automated end-to-end delivery so that it makes easy for you to deploy the software into production. The final stage is where you have automated all the process from the time that you check in, it goes into production in one go. So in that case, you have created a continuous deployment pipeline. Let's go through a high-level design of a continuous integration system. Let's say you have a website running behind a load balancer. And this load balancer points into two containers running version 1. We already know how to configure this kind of a setup. Let's say at some point in time, the requirements changes and the time comes to publish a new version of the software. So the developer comes in and he's going to publish, create a new website, make some modification, and then publish that software into the source control system the team is using. So it can be something like GitHub or Bitbucket or Microsoft Team Foundation server or Visual Studio Team Services. You can create a trigger to kickstart a continuous integration task where the continuous integration system is continuously monitoring what is happening to your source control system, And whenever it detects a new change happens, it can start a build process. So build system like TeamCity or Microsoft Team Foundation Server or VSTS or some other thing like Jenkins usually operates in a concept called build agent. So the build agent can be an EC2 instance. For example, if you are using Microsoft VSTS, which is a hosted version of Team Foundation Server, you can integrate it with a build agent that is running on Amazon. So this build agent will have all the tools like Microsoft Visual Studio MS Build tools and some dependent libraries already configured to build the software. The reason why you usually have a build agent instead of building the software in the build system itself is that you may have some special software that needs special hardware configuration or operating system requirements to build. An example would be, imagine that you have a software that is supposed to run on a 32-bit operating system, but this system may be running on a 64-bit operating system. Maybe this is running on Windows environments and this build agent has to run on, let's say, an Apple Macintosh environment or some kind of an IBM special environment. So once you, what you do is like you configure this build agent and then link it with this build system so that it communicates, and the build system then tell a build agent, hey, I have a new build task, go there and then take the source control from the source control system and then download it and build the software. So the build agent will kickstart a build process, and in this case I'm going to build a containerized environment, containerized web application, and then at the end of the build process it's going to create an image and then publish that image to Amazon ECR. Usually this build agent can execute command line commands, or it can execute PowerShell commands. Because we have command line and PowerShell integration with Amazon ECR, you can easily integrate with your existing build agents. So once the build agent completed the publishing the image into Amazon ECR, it's going to, let's say, invoke a PowerShell command and then say, hey ECS, I have a new image on Amazon ECR. Go there and then orchestrate that image as a new instance of containers. You can also invoke any other orchestration engine if you use your own custom orchestration engine, or you can even invoke some other third-party orchestration engine that you may find in any other cloud service providers. So what happens is that so the ECS is going to invoke this orchestration piece. It's going to invoke create a new containers. In this case, the version 2 is created. So at some point in time, it's going to pass through the load balancer health checks. And what is past the health checks, the load balance is going to direct the new traffic into the version 2 and then slowly decommission the version 1 of the containers. So after that, you have the version 2 of your software running on Amazon ECS. You can separate which parts are managed by which teams. For example, this whole piece may be owned by the development team, and this piece may be owned by the production team or the team who is responsible for day-to-day operation of the system. Let's go for a demo and then observe how this kind of a system works. Here I have a sample ASP.NET web application that keep tracks of the name of the pet, owner of the pet, and how many steps the pet took. So as of now, you can see that the pets are lazy, they are not walking a lot. If you go to the info page of this web application, you can find that it's backed by 2 container instances. So if I refresh it, you can find that it's doing round robin load balancing between the 2 container instances, and it's running the version 1 of the application. So in my build system, I'm using, imagine, Microsoft Team Foundation Server. So this is the TFS, and this has something called a build steps. So if I go to the build steps, you can find that I'm taking the source code from the source control system, downloading some NuGet packages. These are some libraries that are needed to build my .NET application. I'm then executing an ms build task to compile this software and then to build it. All our APIs are exposed as PowerShell, so we are now executing some PowerShell command to publish the image that got created as part of the previous step. All our APIs are also exposed as command line commands, so you can now execute another command line command to refresh the image that Amazon ECS service is using. So back in my Visual Studio, imagine that this is a developer now who is making some changes. So instead of saying application 1 version number 1 that we saw before, let's say we are going to call it application version 2, and I'm going to make some modification into this source. So after that, I'm going to commit these changes. So this is a developer submitting after making the changes. So I commit all these changes. The Team Foundation server is configured to detect any changes. So what will happen is it will realize, hey, there's a new change in this system, and it's kickstart a build process. You can find that the build process is as of now running. And as part of this build process, it's going to execute those steps we discussed a moment ago. So it's building the software, and then after build process, you can find that it's creating the image. And once this image is created, it's going to publish this image into Amazon ECR. You can find that only the delta changes are published. That's why the publication speed really matters. Because if you are doing a lot of deployments, you need to have these deliveries going to ECR as quickly as possible. So now I'm refreshing ECS service. If you go to ECS service and then refresh it, you can find the old deployment still in place, but the new deployment is happening behind the scene. So the users of this website will still get the old version. They will not see any downtime. As of now, the new deployment, the running count is still 1. And if you go to the website and refresh it, it's still running version 1 of the application. So the users get a seamless experience, although there's a deployment happening behind the scene. So let's see what is happening. So as of now, the load balancer, still the new containers are in initial state. So from the time that these new containers become healthy, so in this case, I have one container that becomes healthy in this web application, the old ones start draining. And if you go to the web application now and then refresh, you can find that the new version of the application will appear here. Give it some moment. You have the new version and it's a new container ID. So this is how you do a continuous deployment. In the next lab, we are going to focus only few steps of this continuous integration pipeline, which I have marked with a yellow border. The reason for that is that we spending our time learning different build system like cicd, Jenkins, or Microsoft Team Foundation Server VSTS really doesn't add value when you try to understand the concepts and the steps involved in doing the automation. Learning a build system like Microsoft Team Foundation Server, cicd, or Jenkins, or Bitbucket, or any GitHub itself can take days. So your company may be using different build system, but what we are going to learn is how to use PowerShell to do some automation so that you can provision those scripts in your build agent, regardless of what kind of build agent that you use, maybe Jenkins build agent, maybe TFS build agent, and then integrate with AWS services to automatically build and deploy the software. These build systems, sometimes they demand certain licenses. So if we configure them on AWS environments, it becomes a bit tedious to execute these labs. And also when you try to configure these Team Foundation servers or cicd, it can take days. You need to do a lot of installation, configurations to get them working, and then registering this build agent into these systems can take some time. So what we are going to do in the next lab is going to simulate this build agent with our lab machine or our development machine, and then write some PowerShell scripts to automatically deploy some containers into our cluster. So if you know how to automatically build the software and then create an image and then publish into ECS, you can easily integrate with your existing systems. For example, in the case of Team Foundation Server, you can easily add a PowerShell task that can execute a PowerShell script. As part of this PowerShell task execution, it can execute the steps that you have defined. So in this case, for example, I'm specifying a publish Elastic Content Registry. We already saw that. And if you know how to code this, then integrating with any build system like Jenkins or TFS, TeamCity is super easy. Important thing to remember is that this build agent has to have enough permissions to publish images into ECR and then to do some service refresh in ECS. But we are going to use in our lab environment, our lab machine, which has enough permissions on Amazon ECR, Amazon ECS to do this kind of modification. So we are safe to go. But if you are going to integrate your existing on-premise, let's say a Team Foundation server with AWS, what you will do is you will spin up an EC2 instance, run that build system specific build agent on that machine, link it with your on-premise environment, and then when there's a new build task, that build task will get scheduled on this build agent. Given the fact that the build agent has enough permissions, it can easily publish images into ECR and then refresh the services and ask the ECS to orchestrate the new containers. So in the next lab section, we are going to explore certain ways that you can write some PowerShell script to do the automations that we want to automatically deploy containers.